Okay, now let's talk about diode rectification. Okay, so this is the basic circuit of the diode rectification, right? Usually we say this circuit as a bridge diode rectification circuit. Okay. Uh, Take a look at it. Let's look at the first question. An AC power source provides a sinusoidal voltage of 220 volt RMS at a frequency of 60 Hz. It is connected to the primary side of a transformer with the turns ratio of 20 versus 1. What peak voltage can you expect on the secondary side of the transformer? So here is a transformer. Here is the AC power source. Okay, so in the first question, we don't have to think about this part. Just think about here. Okay, let's make a solution. So first thing you should know is about the equation of turns ratio and voltage equations that represents the turns ratio and the voltage's relationship. And yeah, this is it, right? Oh, ugly rectangle. Oh yeah, this is it, right? So, and one is meaning the how much winding is did at the primary side, and two is meaning the how much winding is did at the secondary side, right? So let's put on the values and calculate it. N1 is 20 and N2 is 1. Then V1 is 220 and V2 looks like this. Therefore, V2 will be 220 over 20, so it will be just 11 volts, right? However, V2 is the RMS voltage, but it is asking for peak voltage, right? So we should find the peak voltage using V2. Do you agree with it? Okay. So the equation of the peak voltage is right? Because it said this is a sinusoidal voltage, right? Okay. Let's calculate it. The RMS value was 11, right? So the peak voltage for V2 will be 11 times root 2 volts, and it will be almost 15.5 volts. Okay, so this is the answer of the first question. Let's move on to the second one. Second one, explain the role of the capacitor in the bridge rectifier circuit. I'll not write down all of the explanation in this small area, so I will explain and explain the keywords of this question. Okay, I'll just explain the keywords of these questions, and you should think about it. So, what is the role of the capacitor in the bridge rectifier circuit? Actually, the most important role of the capacitor in the bridge rectifier circuit is smoothing the output filtering effect, and ripple reduction. Okay? The most important thing is smoothing the output filtering effect and ripple reduction. Okay? So first, smoothing the output. Capacitors connected across the rectifier's output terminals operate as filters, right? So holding charge during the rectified waveforms peak and discharging during the throats. Okay? So this operation smooths out the output voltage and reduce ripple. So this is the first one's explanation. Let's move on to the second one. Filtering effect. When the voltage exceeds the stored voltage, the capacitor rapidly charged to the peak voltage of the rectified waveform. When the voltage drops during the lower regions of the waveforms, the capacitor discharges into the circuit, filling the gaps and maintaining a more consistent voltage level. This is a kind of filtering effect, okay? And the final one, the ripple reduction. This is very important. This is related with the question number, or not actually not a number. Question D. So listen careful. The capacitance determines how much charge it can remain and how quickly discharges it, and resulting in a smoother output. Okay, so as a result, bigger capacitors are frequently employed to effectively reduce ripple. Okay, good. Let's move on to number three. Oh, now number 3. Question C. Briefly draw a waveform diagram at points 1 and 2. 1 is here. 2 is here. Okay? The 1 is meaning before the capacitor, and point 2 is meaning after the capacitor. Okay? So, in point 1, it'll be just draw like this, right? However, after the current passes the capacitors, as I mentioned just before, because of the charging and discharging effect, the wave will change like this way. Okay? So, this is an output, and this is also an output, but it became smoother, right? So, smoothing the output matches with this waveform diagram. Okay? Good. Let's move on. Question D. Explain the relationship between voltage and capacitance. How does this relationship impact the waveform? Actually, there's an anti-proportional relationship with these two values. So the higher voltage causes less capacitance. Okay, the higher voltage causes less capacitance. Okay. The capacitance of the capacitor determines the smoothness of the output waveform. Therefore, if the voltage goes higher, the smoothness of the output waveform will decrease. Okay? So this is the impact of the waveform. Okay? Smoothness of the waveform will decrease. Okay? Okay, good. And next one, let's explain about the Zener diode and briefly draw a waveform diagram at the point after the Zener diode. Okay? So here is the Zener diode. And let's explain about Zener diode. A Zener diode is actually a specialized type of semiconductor diode that operates in the reverse breakdown region of its voltage current characteristics curve. So the first keyword of the Zener diode is reverse. Unlike regular diodes that are designed to conduct in the forward direction and block the reverse direction, Zener diodes are engineered to conduct current in reverse BS conditions once a specific voltage known as the Zener voltage or breakdown voltage is reached. So the second keyword will be Zener voltage breakdown voltage. Okay? Yeah. In the bridge rectifier circuit, the Zener diode can regulate the voltage. Regulate the voltage. This is the fourth keyword. By connecting the Zener diode and reverse VS across the load, and it can maintain a nearly constant voltage across the road, effectively regulating the output voltage. And this is meaning that after the voltage passes the capacitor, it will form like this. But after it passes the Zener diode, due to the regulation of the Zener diode, it just looks like a straightforward because this part will get rid of it. Okay? Therefore, the waveform diagram at the point after the Zener diode will just look like this way. So finally, AC changes as DC, straight line DC, right? Good. Okay, and one more characteristics of this circuit is that there is a resistor over here. Okay, this is Zener diode, and just before the Zener diode, there is a resistor. Why there is a resistor is the question F. Why should resistance be placed before the Zener diode? This is actually because we should protect Zener diode. So the keyword of this part is protecting the Zener diode. Okay? The series resistance can offer some level of protection to the Zener diode by limiting the current during transient conditions, spikes, or voltage surges. You shouldn't have to know about these kind of components, but yeah, I'll just mention it. It acts as a buffer and helps prevent sudden Z currents that could damage the diode. Okay. So we finish it question 3. Okay, and the next question is about capacitance. Okay, so I'll stop here because I don't want a long video, so I'll stop here and I'll do it at the next video. Thank you.